All right, we're going to start up very soon. Just got to get ready. Maybe get some more iced tea rolling. You know how it is. Got to have some iced tea rolling. Okay, pre-stream questions. Anyone wondering anything about what we've been doing today that's not a total repetition of the things I already explained? And the type checker. If a type is unknown and gets halted, does it just get sent to the back of the queue and wait for all the other files to get parsed before being checked again? Or is there some intelligent way of checking? So what happens... There's a few different ways that things happen like that, but the one that most meets your description, actually, when it's time to pause because something isn't ready, you know what wasn't ready, right? And so, what is that noise? Something out in the hallway. So you know what wasn't ready. So you go on a list on that thing, and then when that thing becomes ready, then it wakes you up. So yeah, it's a little more smart than that. Any good books about programming? Sorry, no. I have no recommendations. No recommendations. All right. Starting in 3 minutes or even less than that. Starting in 3 seconds. What is the current scope representation problem? I explained all that this morning, so it's a long explanation. I don't want to repeat it n times, but you can go back and watch that video if you want. How sensitive is the eye tracker on my head position? I don't know. I kind of have a relatively small box that I can be in, actually. I think it would be good if they worked on expanding that range a little bit. Let me look up, somebody said the other day there's also a Steelseries Eye Tracker. It doesn't have a very good rating on Amazon. It looks like it's actually similar to a previous version of the Tobii Eye Tracker. It's just branded Steelseries. So the one I have is, I think, a little newer. But this one, the 4C, the model that I'm using, came out at the end of 2016. So maybe they're working on a new one. I don't know. I don't know, man. I don't know. Yeah, the Steelseries one looks not that different from the one that I'm using. A little different. There's Track IR5 Premium Head Tracking for Gaming. That's probably a helmet thing and not an eye tracker. Gesture control armbands. Yeah, optical head. What does this thing claim to do? Can it tell exactly where I am looking? I don't know, man. Was there a stream after I went for breakfast? Yes. But half that stream was buried in debugging. But by the end, we had debugged our situation. And now we are sort of back and ready to do the next thing. Where the next thing... let me get my camera good. So the next thing is the following. I really should get a neutral background to put over my books or something. So what I had done in the previous stream was I factored all the scope manipulation stuff out to this scope.cpp file, which is new. And there was one particularly scary thing that I separated out from the rest of the scary things in its neighborhood. Oh, this is up way up in the camera here. So I filtered that out. Maybe I actually want, I don't know where I want the mic. Is there a big difference in audio quality between the mic being here and it being down here? Like, how does that sound? Anyway, so this splice appears to be working fine. That was the scariest thing. Now that we've done all this, the next thing is to actually make add to scope do something. So as far as I know, this right here is the only spot that actually adds things to that array for data scopes, right? Now, let's just double check that. Let's just say members.add. Of course, there's other things called members. Okay, constants block is fine. Arguments block is fine. That's something different. Yeah, this is some debug thing. It's different. Returns block is fine. This is what we're talking about right now. This is our new thing, the splicer. This is only for imperative blocks. Okay. So we can do our assertion here. Assert not block flags and block lookup is large. Okay. because we're not going to do this for imperative scopes right now, just for declarative scopes. It may be exports members dot. That's not a member add. Arguments block. Okay, so we're clear. This is the only thing that we need to worry about. Okay, the first thing I'm going to do here is change that mutex because we sort of pasted code here twice, which is fine because it's so simple. But now that it's about to get more complicated, we will not want to do this. So we're going to do this, and we're going to do this. And then we'll do our job, whatever it is, and then we will unlock our mutex down here. And let's just test that, because why wouldn't we test that? Why wouldn't we test that? Okay. Boom. So Sokoban, run tests, crank-a-tank bank, balanka-nanka. Okay, quality is fine for both microphone distances, I am being told. Great. Okay, so well, what now? Well, we get to make this logic more involved. So potentially inside global namespace mutex. Okay, so if okay, we're always going to add to members. So this part can just stay there. That's totally fine. If block members.items is greater than or equal to, let's just make this constant for now, const int max entries for small block equals 16. 12. I don't know. We don't know what number it should be. We really don't. Max entries for small block. Block type is block data declarations. And not block flags, and block lookup is large. Convert to large lookup block. Okay. If block flags and block lookup is large, we're going to add this to the hash table. Where by hash table we mean this other stupid array that doesn't do anything yet. Right? So we had other linear members array. Dot add decal assert block other linear members array dot items is equal to block members dot items. That's not, well, I guess that had better be true. If that ever fails, we're in trouble. Yeah. Yeah, okay. It may fail for reasons of complexity of the compiler, and then we'll have to look into it. Okay, so convert to large lookup static void convert to large lookup block. Well, we want to set this flag eventually. And, well, warning, we may well be inside a mutex when we call this thing here. You know, that's what I want. So people always ask me, like, what do I want in a debugger and program visualizer? Like, I want to know what code coverage I had while holding what mutex, for example, right? Like, tell me that kind of thing. Okay. Block assert block other linear members array.items is 0, and we'll reserve block members.items, and then for block members add it. All right. Well, let's try that out. Now, this isn't really going to do anything yet. I mean, it's not a full test yet because we're only putting stuff in here. We're not using it yet, right? And the whole point is that we're going to use that. Okay. Well, we didn't crash compiling Sokoban. That's good. Of course, we won't know if that assert went off because we're running a release build. So we'll run debug builds of this stuff. Let's compile that while this is going. What's a mutex? It is a way that you organize different threads so that their computations do not destroy each other. Shouldn't the convert to block conditional come before the block above it? No. The reason is you could either put it here. Well, look, if you put this up at the top, well, that's fine. The one, it could be at the top, it could be at the bottom. Because we have to take all the old members. So we didn't add it here because it wasn't large, but we're going to add it here because we added it here and we're converting it, right? The one place that this cannot be is in the middle, right? Are we going to have higher level game related things like font rendering? Yes, we already do. We already do. Okay. Okay. I mean, we have STB true type, but we also have a wrapper over that that does some layout stuff. You know, I did a whole stream a couple of months ago about the philosophy behind the libraries. So you can go look that up on YouTube because I talk about how I want to do it versus how C++ does it and all that. And we go into a great amount of detail that I could not reprise here accurately. Okay. Okay. We compiled the debug build, so let's just make sure that assert doesn't go off. It's going to take a while because this debug build is hella slow. Okay, the other thing is our compiler has probably got a little slower, probably maybe not measurably, I don't know, maybe measurably, because we're now maintaining this extra array. And we're not getting any benefit from it. In fact, we're just getting worse, memory usage. So this is super slow because our debug compiler is full of assertions and stuff. Let's do this. So this is looking pretty good. Great. Okay. Now, let's check this in. Screw it. Checkpoint toward scope revamp. I don't know, whatever. Okay. Okay. So now we want to change lookup. We want to say find declaration helper. That's what we want. So we do all this and then, oh boy. Well, how do we do this? Because we want, C++ doesn't really give us a good way to do what we want here except to put this giant thing in a macro. So like, we're looking up a declaration by name. And we want to do all this stuff. This is where just C++ just sucks. Of course, I don't have a super convenient way to do this yet. Sort of do, but we'll have a better way to do it. Oh, right. If we're non-ordered, then we don't do any of this stuff. And this current large block thing is only for non-ordered scopes. And so actually we can just paste all of this. So here we're going to say, if it's a large lookup, we do one thing, else we do another thing. Right? And we're going to say, cut and paste from below. There, boom, boom. Okay. Instead of members, what was it called? It was called other linear members array. It's a long comment, so I'm not going to duplicate it. Okay. Here we go. Assert okay. So that's not too bad of a cut and paste job. Well, let's see if that actually works. Current scope. Well, oh, we built the debug build, so that wasn't a test of anything. So in principle, we should be just a little slower than we ever were. Oh, undeclared identifiers. We did not do a good job here. Let's go into debug build. What did I do wrong? Tell me. Tell me. We're not really profiling so much as just making it faster. Okay, this is weird. So we're going to assert that. And so we're ignoring placeholders. Well, and like I said, we can't get to anything down here. Did I mess something up here? Like what? Did I indent this wrong? I don't know, man. I don't think that assert's going to go off, but we'll see. If it does, then yeah, the aimbot is helping us debug, man. Okay, this is very strange. So I guess I guess I'm just going to step through it because I don't really know what else to do here. It just seems so simple, and yet, of course, it's probably something really dumb. It's probably so. Here, let me just do this. So we never do this large block lookup. We're compiling the release build and not the debug build. Okay, so we don't know if the assert went off. I hope somebody on stream caught that. No, you guys are useless. Nobody caught it. Okay. Now let's see if we actually successfully compile. If we do, I'll take off that 0, and we will see if the assert goes off, which I still don't think it will, but it might. It might. Oh man, we should make the debug build faster. I want to profile the debug build and just figure out what assert is taking all the time, because it's probably like 1 or 2 of them. Because it'd be nice not to take 30 seconds. Okay, well, let's go back to this then. Does the assert go off? Does the assert go off? What methods are being generated by metaprogramming? These? Yeah. But this function itself, oh, I guess it is being generated by metaprogramming. So what does that mean? That means there's a placeholder for it. It means there's a placeholder for it. It's not liking some things that are procedures and have placeholders. Now, oh, it's because when we replace a placeholder, we drop things directly in the members array, and we need an exception for when it's large as well, right? So is placeholder here, right here, bro. If scope block flags, then what's it called? So even though what I'm doing right now is very specific to this dumb temporary array, when we put in the real data structure later, we can just look for block lookup is large, right? That is the problem. So when we replace a placeholder, we're not replacing it in the large blocks data structure. See, language features interact in this way. Everybody just thinks like, oh, just have this one feature, it'll be fine. And it's like, actually, features make things complicated. You know what I'm saying? I am not that used to this chair again. How do I get more up? There we go. Features make things complicated. Every feature. Every feature. Will this be comparable in speed to C? It should be, and then, you know, hopefully we'll make whatever decisions are necessary. And then maybe we can make some decisions about aliasing and also about allowing programmers to have high-level ways of determining, telling the compiler how their program should run that should enable you to go faster than C. Like, why aim low? I don't think you should aim low. Okay. Well, this will take 30 seconds and say, you win. You win. The large-small distinction is the whole point of what we were doing. You can, if you want an explanation for that, you can watch the stream from this morning where I go into the whole idea of what we're doing. Okay, it compiled. That's great. So let's release build it. Let's see how much speed we've lost. Hopefully not too much. Of course, we're going to get, the whole plan is we get way more back. So what were we at? We were at 1.2 seconds. So we're like 1.28. We're a little slower. Let's run that again. 1.3, yeah, that's about where we were. Yeah, I remember this 0.68 in the front end is about where we were. So that's all good. This is all very good. We have not slowed ourselves down much by adding this thing. And now we start doing the good action. The good sauce. The bottle of good sauce is now coming out. Large path implemented. The bottle of good sauce is coming next. Okay, so I don't like templates in C++, and so what I'm going to do is just copy the hash table from something else, like the atom table that we already have, into another file. Maybe, well, we'll look at the atom table. We might be able to use it as is, but if we don't use it as is, then I'm just going to copy and paste it, which will cost us in terms of lines of code, but I'd rather have more lines of code than a C++ template monstrosity making my life terrible. Construct foo int x5 be the same type as struct foo int pointer x. No, those are never going to be the same type. Every struct is actually a different type. However, you can very easily write a function that assigns one to the other generically, right? So you can write a function that'll sort of duck assign from any one thing to any other thing, so that you don't have to write that per different function. How difficult has the work on the compiler been compared to the witness or braid? I mean, as a whole, it's simpler software than the witness, definitely. However, because I'm doing it all myself, or what, I mean, some people have come on to help since then, and so they've got modules on the periphery, but some of the stuff in the core was pushing the threshold of what I am able to organize in my brain and know how to do. And so it got hard sometimes, but then I always find a way to simplify it, right? It's like a Zachtronics game. But in terms of the magnitude of the endeavor, it's much harder to make the witness than to make this compiler. Unfortunately. Okay. Now, what now? A hash table. Let's go look at the atom table. So this is 159. We have Robinhood hashing turned off because it's not really worth it. So we can delete those lines of code and we'll have a simpler table. Okay, let's look at what we've got here. We resize. We can hash a string. Well, we don't want to copy that. I mean, we can use the same string hash, but we don't need to because our identifiers are all interned. So we just need to hash an integer, which, like, I'm just going to mod it by a prime number right now. Like, that's just going to be the story. What is the fastest? Someone is Stack Overflow is saying use a standard : hash. Yeah, bite me. I'm just going to mod it by a prime number. You guys, you're not, these people on Stack Overflow are benchmarking the actual hash function. You want to benchmark how well the table behaves. I think that's what they're benchmarking. All right. Okay, well, so we've got a string hash. We're going to not Robinhood it. So I seem to have this set up to be pretty general, but it's made just for atoms. And like I said, I don't want to templatize it. So we are going to go into scope.cpp, and we're just going to define new stuff here. This is someone's pointer hash off Stack Overflow. Why do people make things so unreadable? U32 hash pointer. I guess we'll leave it const. Okay. U32. We're just casting down to U32. We're taking the low bits. Okay. Here we go. We're going to go to atomtable.h, and we're going to go scopetable.h. Boom. And in terp, where we include scope, we're going to include scope table. I'm just adding files all over the place today. Okay, we're going to take out the Robinhood. Robinhood is gone. Robinhood is gone. Robinhood is gone. We do not care. We do not care. And okay. Instead of atom, well, we're going to say scope table struct well, what am I doing? We don't want to hash the pointers. That's stupid. We already have hashes for the atoms. Yeah, okay. So scope table. We want to pass a declaration. Why am I having the bucket and hash there? That's something to do with how I did the atom table. Okay. Okay. They're getting rid of digraphs, finally. They might make insert2's complement defined behavior finally. Oh my God, that would fix so much about C++. Bro. Okay. Bam. these were all, well, I might want those, I don't know. Inline asked declaration. Like, when, how did I use this? Oh, atom table dot find. So I would get the bucket index. Yeah, I called desired bucket with the hash. There's no reason to. I guess the reason to do that is to add. But we're not going to worry about that yet. Oh, yeah, yeah. Whatever, man. Okay. Find. Okay. If the hash array bucket is hash, auto decal is declaration array. Assert decal. If decal identifier name, we're going to assert decal identifier. Decal identifier name is equal to atom, return atom, return decal. Okay. So that's our thing there. And then asked declaration decal in bucket U32 hash. If so, desired bucket. Yeah, we'll yeah. Resize items. Hash array. Is hash. Declaration array is decal. Hope I'm not screwing this up. Desired bucket scope table hash and table mask. Okay. So I don't know. Let's not forget to add this to the project and to source control. Yeah, and let's see what happens if we're not using this yet. We're just going to try to include it and compile. Add, okay. Yeah, I messed things up. I admit it. Okay, let's check. Because this is C++, decal let's not pass the atom. Okay. Okay. We're in almost business. Hash pointer. We don't need that. That was during a phase of our youth when we didn't know what the hell we were doing. Why is there a while true loop? Because you use those sometimes. Like, that is a very useful construct if you're programming. Have you ever heard of programming? It's this thing where sometimes you say while one. That's what programming is. Okay. Now we're going to be so cheeky. We are going to go to not ast comma g. We're going to kill that. We're going to go to ast.h. And we're going to say we've got a scope table, large lookup table. Let's see what happens there. Unknown override specifier. Oh, God damn it. So is this something about constructors and whatever? Unknown override. Okay, this thing doesn't have constructors or anything. Maybe I'm including this before anything else. Yeah, so let's struct atom, struct ast declaration. Oh, you know what? We can even make large lookup table go through a pointer. Let's do that. Just to, if we want to make it not go through a pointer later, we can do that, but we do that now. Oh, let's make that null. Just for clarity in debugging. We don't need it because we have a flag that tracks whether we're using that or not. But, dude, I so don't trust Visual Studio. So, by the way, I determined this empirically the other day. You know, it's got these timestamps of like, oh, this file hasn't changed since the last build. It determines that at the end of the build. So if you modify a file in the middle of the build, after it loaded it, and while it's linking, for example, it'll just consider it up to date. Quality. Quality. And everybody says, oh, your new programming language doesn't have an IDE. Why? So it can get files wrong? Like, come on, guys. Come on, guys. Functional programmers are having a heart attack. Look, functional programmers have enough problems. Don't wish heart attacks on them. Okay. So now we've got a thing with a hash table compiled in. Here's what we're going to do. We're going to keep our stupid array in there. We're going to have like 3 separate things going on. We're going to put the hash table in there and gradually switch everything over so that that works. And then we're going to take the other array out. Okay, so we're going to say commit scope table added but not yet used. Magumba. Let me check my continuous integration server. Yeah, nobody's getting upset yet. That's good. Okay. So now, we've got our scope table. Yes, we copy and pasted it, but it's only 100 lines. It's fine. Then we will go to scope.cpp, convert to large lookup. Okay. We will. Let's pass an interp. So What is my get memory macro? Get memory. Okay. So, convert to large lookup. Table, auto table is get memory interp scope table. And then block large lookup table equals table. And here init, what's our init do? It's not here. Oh, look, we have more code. It's more than 100 lines. These are not in the header, you know, because they don't have to be that fast. This all looks reasonable. Just verbatim. A lot of people would say, why are you not using templates for this? And my answer is, bleh. Okay. All right. Whoa. Name hash. Okay. I don't know. Maybe that's enough. Atom size. Load factor percent. What did we set that to for the atom table? I don't know. Oh, it's in the CPP. Okay. We'll start with the same thing for this. It's another tunable factor. How did we use that? Yeah. Integer multiply, integer divide. Load factor, oh right, we forgot to rename it. We must do that. Didn't rename the const. I'm not sure what you mean. Atom 485. Add decal bucket hash. Okay. All right, we're still around. Oh wait, that's not the. We're still in the same neighborhood. Maybe a little slower. It's hard to say. You know, there's a certain amount of random factor. Yeah, 0.68, 0.69. That's okay. Let's run tests. So we're supposedly allocating these tables now. We're not yet adding things to them. So let's do that before we check in our next milestone. This convert to large lookup. Well, we add it to other linear members array, and then we also say okay, if it identifier name block arrow large table add it desired bucket table hash. All right. And then here, when we add, because we are live in large, I should have called it live in large. That's my flag. Well, we do the same thing. Except it's called decal. Okay. Let's see if that slowed us down at all. It might have. It's very real danger. Very real danger. Oh boy. Mistakes were made. I'm not saying by whom. I'm just saying mistakes were made. Mistakes, or maybe there's not mistakes. Maybe, you know, like people say sometimes, certain kinds of people say, you know, there's not really anything objectively right. Like maybe I just like it if my compiler crashes when you try to compile a program, you know? That's just my opinion, and my culture is just as valid as anybody else's. So, you know, you can't say that's a mistake. You can't say that's a mistake. Don't tell me that I made a mistake. It's just my life experience. This is my lived experience of how my compiler is. It's my lived experience. Oh my God. Okay. Boy, this sure is taking the whole 30 seconds. Oh, did it? No. It's going to take more than 30 seconds because we've added more assertions in all our operations that we're doing, I guess. Maybe the assertions in the scope operations is what's taking all the time. Where are we at right now, homie? What's going on? Web is the future. It's true. Yeah, I tried to sign up as a Twitch affiliate, and their sign up web page keeps rejecting me because of a bug, I think. So I may not be able to be Twitch affiliate because of the web. That's just how it is. What is going on? Are we infinite looping? Like, what even? Oh. Look at all those bytes that we are trying to allocate. That is like a -1 next to a CD, 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 CD that then has had some math happen to it. Oh, Nelly. Oh, Nelly. Okay. What? How did we get that for n bytes? N bytes. Extra. Well. Table. Oh, I didn't call init on my thing because I got distracted. I was about to call init on it, and then I was like, oh, but we don't have that. Right? So when we allocate it, I hope somebody caught that. No. No, of course not. Scope table initial hash size. Thanks, chat. God. I'm going to figure once we start getting large, we're going to be at least a little bit larger, you know. You know. Let's try this again. Let's just go for it. Let's assume that calling init was all we needed to do. Okay. We're still taking about the same amount of time. That bodes well for, whoa. Front end time 0.7, that's the highest it got. Okay, this is good. Really, that works now? I thought x64 was crashing. Okay, now I'm freaked out. Let's run the LLVM version 2. That's working. Let's run tests. Blammo. Okay, let's check that in. We are adding items to the scope table, but not yet reading from it. But that's the next step. That's the next step. So now when we are here, See, this is like I was saying, you decompose your problem into smaller problems. The problem we solved earlier today was just getting the structure of the rest of our program ready to do this. That took an extra 2 hours due to a dumb bug that I made, but we partitioned it from this, right? And now this is actually turning out to be pretty easy. But even this, I'm breaking into steps. Like, let's make a hash table. Let's make sure it compiles. Let's add items to the hash table, right? And now it's like, okay, let's read things out. So we have a challenge here, which is that we have to change two things at the same time. We have to replace. I'm probably just going to make a replace function. Because when we, in this placeholder thing, yeah. Okay. So first of all, here we're just scanning for stuff. And we're going to have to change the logic slightly. Okay, so this is just a thing that is no longer a thing. Instead, we say, what are we trying to look up? Name. So we say current scope, large lookup table, I guess it's called. Find name desired bucket table comma hash comma hash. All right. You might well ask, why am I making this so laborious? It's just the way that seemed okay to factor it when you're not concerned with being too user-friendly and you want modularity and stuff. It's fine. Okay, found. If found, well, if not found, we can, well, if found, this is going to be a little bit slow, but I just want it to look structurally like it looked before so that we have the minimal probability of messing things up. Did I check in before this? Seems like I should have checked in, but we can toggle back. Okay. If it's a placeholder and don't detect placeholder, well, detect placeholders. I thought there was something about that only being, I don't know. I don't know what that's for, but oh, it's for reporting errors. Okay, so if So we can't do the continue because we're not really in a loop. And if we continue this outer loop, we have to like manually do this. I'd rather just fall down to the bottom and hit it here. Doesn't really matter, but you know, we're trying not to mess things up. So if no skip, return found, right? Okay, that's not too bad. Okay, let's see if that compiles. We still have to do the other thing. Yeah. Okay, we still have to do, not that, we did that, we did that. This one. So, special hack to scope table find that replaces the old declaration when found. Okay, so where is our find? Okay. It's called scope here, not current scope. Found is table find name, desired bucket table hash, comma, decal new. Assert found is equal to decal old. Okay, this whole thing, check for redeclaration is looking over the members array. So we need to speed that up. We forgot about that. Check for redeclaration. That's going to be fun. Actually, it's going to be pretty easy. But we can do this part. We can get it functionally correct without having to do that. Okay, so we're going to find, and we're going to ask declaration replacement equals null. Find replacement. Okay. They have the same hash and all that because they're the same identifier. We're just filling in the placeholder. Who knows if this is going to work? I don't know. I don't know if this is going to work. Does anyone have anything positive to say about Prolog? It is really, 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 really slow. But for constraint-based queries, like if you want to solve those IQ test problems where like what amount of change adds up to $3.75 or whatever, then that's a trivial Prolog program, you know. Please work. Please work. Oh, yeah. Oh, yeah. Okay. All right. So we saved some time, right? Because we were at 0.68 before. Now we're at 0.616362. So we saved 10% of the front end time already. And we haven't done that check for redeclaration thing. Let's make sure it frickin' runs. And let's run tests. Cowabunga. Okay. And now to make sure we're doing a good job, let's now go and remove our crutch here, our other linear members array. We should, in principle, be able to get rid of all of that. That's gone. We're getting kind of close to Miller time here. You heard I don't like Celeste. No, it's not that I don't like it. It's just, it didn't totally grab me. But I might play it some more in the future. It's not like I have a philosophical objection to the game. It's just sometimes some games you're really into and some you're like, okay, that's for other people. I mean, I have friends whose opinion I respect who say it's a good game, so that's fine. I'll give it a try again. All right. Well, we're just testing this again. See, it's just funny. Like, we spent 2 hours today on a dumb bug, but the actual supposed heavy lifting parts didn't take that much work. And now we've got this thing, So I took out the linear array thing. Now we're down to 0.5960. So we're more than 10% faster. We're like 12, 13% faster in the front end time. And we haven't done check for redeclaration yet. So I'm going to take a short break, stretch my legs, and then we'll do that. Use hash table in some places to speed up compilation. Eventually, it may be time to profile, but I don't have a profiler installed on this machine, so maybe I'll do that in a late night stream tonight. Oh, how are we doing on lines of code? 41638. So we're 144 lines up, which is not terrible, considering that most of that is an isolated hash table implementation that we pasted. Okay. Five-minute break. Address questions to... All right, back in a few minutes. Where's my tea? Someone's asking how much of a speed improvement was expected. I wasn't really expecting anything specific. I just remembered that last time we profiled, this was really big in the profile, but I wasn't quantifying it too carefully. And we haven't gotten the whole speed boost yet because we still have to do check for redeclaration. And then, of course, our hash table is totally untuned and all this stuff. So the actual speed boost would come fully later. But, I just wanted to get this in there for now and have it be a thing. Do I still feel strongly about the 80% solution theme you had in the beginning? Yes, very strongly. It is the right way to do this, I believe. How and when did I meet Casey? In Seattle, probably in 1998 or 7. 1997. Something like that. I need advice for a recent college graduate. Well, I don't know. Are you a programmer type of college graduate or just a general college graduate? Would it be incredibly rude to ask me to check out a puzzle game you're making? Yeah, I'm in the middle of doing stuff right now, man. Do I expect this to be something a newer programmer can jump right into? Well, if you want to program in something where you get the fastest results up on the screen and don't mind that much how it happens, then the kinds of systems that do that are different from this kind of programming language, right? And if you're a beginner, it's not a bad way to start to do that kind of thing. Like you could start with Game Maker or something, right? So this is, more a language for people who really want to care a lot about how things work, which is a little different. Although if you're starting with Handmade Hero, that's definitely a show where you care about how things work. And so I don't know, man. Seems like a lot of people are in the OO mindset. That is true. That is very true. What are the possible ways we can try and get more people to think about problems in this way? 80% solutions. I don't know. I think it's just the way people get when they have experience. So if people stopped reading Hacker News and Twitter and just actually spent time working hard programming, they would come to understand these things faster. I don't know. Why are the asserts supposedly so slow? Where does a big performance hit come from? Isn't an assert basically just an if under the hood? Yeah, but sometimes, sometimes you do something non-trivial in the assert. I don't actually know, though. Like, that was just conjecture when I was saying those asserts took up all the time. They may not be what's taking up all the time. But also, if you have a whole loop, the entire job of which is just to check a pointer, right? If you add an assert that essentially checks another pointer or two, you've doubled or tripled the amount of time that loop takes, right? So who knows? Okay. let's what happened to my keyboard? I just yanked it out of the cable. That is not the good way. Okay, if you want to get a lot of work done, don't unplug your keyboard. It doesn't help. Okay. Okay. People. I'm just going to do that so I don't have to do this. And now we have this situation in check for redeclaration. So we have this big loop that's just looking at all the linear members, but then we just have this big block. So I can structure this more like a query, where I'll say ask declaration decl old is null, right? Okay, so this is kind of like the query that we're going to get from the hash table, right? And then we just say, well, if we have no decl old, then this, right? Otherwise, we just go ahead and do all this stuff. And I believe now there's no way to get down here. And we already know this is true. Okay. All right. So that should still work. I mean, it shouldn't if I mess something up, but in my dream world, that still works. Of course, it's not going to help if it doesn't compile. Scope arrow members. Right. Right. Well, we're gonna have to deal with that. But that can be dealt with. Oh, damn it. Yeah. We're going to need some place that records what slot a declaration is in. Because remember, we need to maintain this thing here. So maybe a placeholder declaration holds its index in a scope. That's not going to work because you can insert things before the placeholder if you're the static if. But then maybe we rewrite that. Oh, dude. Yeah. All right, this is going to get a little scary, so we're going to check in before we do it. First, we're going to make sure that what we have done works. Okay, yeah, run tests. Is Sean McGrath doing programming streams lately? I feel like I haven't seen anything from him, but maybe the social media net has not been doing a good job of showing me his things. Prep for next mildly scary change. Okay. Now, we need to get rid of this slot index here. The only time we need it is when we have a placeholder. I could use more memory on every declaration. I mean, but if it's a placeholder, if it's a placeholder, we can abuse my member index in enum. I could just union it. It's like such a big struct. I don't want to keep adding things. A lot of things here could be unioned anyway. We could abuse value register. We could abuse all these things. It's just, also if I abuse things, you know what? That's a separate optimization. In placeholder index within placeholder index within linear members within members array. Okay. The annoying thing is now when we add it to a scope, we need to set that value. We need to set that value. And that costs us something every time we put something in a scope. But in theory, we look things up a lot more than we put things in scopes, unless it's frickin' OpenGL. Okay. Now, before we forget, we need to do this. Oh, man. What a pain in the butt. I need to do that in all of these. No, you know what? No, we don't do this. Okay, replacing a placeholder. I thought of this earlier today and then I forgot. Replacing a placeholder is a rare activity. It's a tiny percentage of the time. Your program will not have very many placeholders. So it's fine if we just get the array in a slow way. It's totally fine. And if it becomes not fine, we'll see it in a profile. Why am I so stupid? Okay, slot index. Ba-bam, ba-bam. If it is placeholder. Which is a rare operation. What's my Emacs? I hate it when you do this. So we have find bool found equals scope members dot find decal old comma and slot index int slot index assert slot index greater than or equal to 0 whatever scope members slot index equals decal new. That's all we had to do. That's all we had to do. That's it. That's not scary. I was about to do this whole extra It's worth being a little bit unhappy when you're about to do something complicated, because it'll cause you to maybe pause and reassess whether you really need to do that frickin' thing. Sean does a stream every now and again. I'll have to watch one. Is this a question mark? Is this a question mark? Okay. All right. So that was about to be a scary change, but then it wasn't. So I don't feel the need to check in yet. Because we're almost there. Now that we don't need the slot index, we can just do the lookup is large situation. We can be living large up here. So if it's large, we do something else. We do this. All right. Now the funny thing is, we're doing check for redeclaration, and then we're doing an add. So we're gonna like look the thing up in the hash table twice in a row. You know, like all of this can be streamlined. Thiggins. Bilbo Thiggins. Bilbo Thiggins. Twice in a row on the table, we can refactor to cut down on this. Okay, but not decal old identifier name, decal new identifier name. Hash, scope, large lookup table, find, name, desired bucket, hash, decal new. So there we go. Maybe that'll work. Things have been working today, and then sometimes things have not been working today. So, oh boy. That's interesting. We're getting the wrong overload somehow, maybe? I was so hoping that we were going to be done, because this is like the last big thing for today's stream, and it leaves so much time to go back and do little things scribbled on my paper. Debug version. See if an assert goes off. Okay. You know, I don't know if I did a debug version before the previous check-in, so I might have screwed something up. Okay. Check for redeclaration, register overload. what is going on? It's a large block. We found decal old. We found decal new. Okay. Neither is a placeholder. So it makes sense that we're down here. This is fine. So we're just trying to register an overload in the regular way. So what? ToString. And register overload says decal old overload of is equal to decal old. Right, but it's not. So we have to figure this out. Like, what did I even... Okay, so how about, let's see. I may have forgotten to run a debug build in a while, right? So let's fall back to this, right? And we will see if we get that assert, because that'll give us some information. We don't. We don't, okay? Interesting. So there is some way in which, oh, I pasted this, and it's got the replacement parameter there at the end. Bro, don't tase me, bro. Copy and paste, copy and paste, copy and paste. All right. Boom. Look at that. Look at that. Run tests. All right, let's see if we got any speed out of this. Sometimes things are easy. 0.53. We were at 0.68 before. So 5.3, 5.4, 5.2. We'll call it 5.3. So we took off 0.15 seconds out of 0.68 seconds, right? That's 22% or something like that. That's pretty decent for one day of work. Now, that's not 22% off the whole compiler, but, you know, there's like a whole half a second here that we can't even control. So we took off 0.15 seconds out of the part that we can control being 0.8 seconds, right? So it's like 20%. That's pretty decent. And we haven't even tuned anything. We haven't even profiled this at all. It's just like, hey. So that, I think, is Miller time for now. I'm going to want to chase down some other notes that I had, but this has been a successful day. I've been wanting to do this for a really long time because you just can't have your scopes just be linear lookups, right? So, yeah. Initial version of large scopes being hash tables complete. 20% faster front end. When compiling Sokoban. That's pretty good. It's pretty good. It's Miller time. Questions and answers. What did we learn today? besides don't make dumb mistakes that cost you 2 hours of debugging? What else did we learn today? Are we all from the Matrix? What's the gnarliest part of the code base at the moment? The gnarliest part is the dependency management for doing the out of order compilation. That is still something where I need to go back and revamp that. I don't know what the right answer is yet, though, so that makes it hard. I need to think about it more. But as we get more of these things off my plate, I'll be able to think about it more, because I'll have less occupying my mind from other directions. Will there be custom allocators? There already are. We learned it doesn't matter mistakes that take 2 hours as long as good progress is made afterwards. That's true. It would have been even better progress without that 2-hour layover, though. Yeah. Do we have virtual machine? It depends what you mean by virtual machine. We do, but we don't. It's not the target of the compiled binary. It's a thing that runs at compile time. Yeah, so we don't target a bytecode like JVM. That's not what we're doing here. Although we could, I mean, we could. It's just, it's not the goal. It's not the goal. It's not the goal. It's been 2 days of hard streaming. We're still going to do some more streaming tonight. I want to stream at least 3 more hours tonight, because there's all these loose ends on this piece of paper. It's about little things. Like I have one that says Constance told me. I don't remember what she told me, but I can look it up. You mentioned in an earlier stream that you should be able to write 1,000 lines of code in a day. Does that include bug fixing days? Not super much, no. So what I remember is way back, even when I was getting kind of started in serious programming, like in games, like if I was writing something that seemed kind of easy, like a data structure or whatever, that didn't involve hard problem solving, it was more just like regular programming, that I could do about 1,000 lines in 5 hours, and then I would be kind of tired. So 1,000 lines in a day is kind of a roundup. That was my good productivity level in 1996 or 1997 when I was 25. Now, obviously, that's not average, right? So this whole compiler is 41,000 lines. But I've worked on it more than 41 days, probably, yeah, for sure. So that's not an average at all. It's like a burst. If you're cranking, you should be able to do that pretty easily. Like if I'm cranking nowadays, I probably could do more than 1,000 lines for sure. It's just, I don't have that many easy programming problems. How much of man-caused hurdles versus creative tax needed to solve genuine programming? Well, I'm not sure exactly what you're asking, but it varies is the answer. It varies. I've been working on this for 3.5 years, but only about 2 years full time, right? Before that, we were shipping the Witness. And so I was working on this just part time. And the past 2 years that have been full time have been on this plus the Sokoban game, right? So it's really, this 40,000 lines plus the 50,000 or so equivalent that's in Sokoban. Somebody gave me a script for Clock that should do a better job of counting those lines, but I haven't installed it yet. Someone was very nice and emailed me one. So it's about 100,000 lines total, rounding up, for the compiler and the game. And they're both pretty complicated systems, so that's pretty good. And of course, these 2 months that have been full time, or 2 years that have been full time, I also took several months off to do stuff like, ship the iOS version of the Witness and stuff. There was like 1 to 2 months, probably close to 2, that I only did that. So, and I have to run a software company every week, and that takes a certain amount of my attention. But we're doing okay, given all these factors. Things are moving along. The easy problems probably just got copy-pasted from previous solutions. Well, I'm not counting copy-paste. When I say 1,000 lines in a day, I mean like you legit are writing that from scratch without a reference. People should be able to do that. But yeah, I certainly have been working on this for more than 41 days of full time. There's no question. No question. Maybe there is I don't know. It seems like a lot. Do we plan to make a written spec not for a really long time because it's in flux? The only use you found for Node.js is as a Clock downloader installer. All right. I find it super distracting when someone watches you programming. Am I more productive when I am not streaming? Yes. If I'm trying to solve a really deep problem that is hard, I probably won't stream it unless I'm really unmotivated. Because, when I'm sitting here streaming, a certain amount of my brain is being occupied by the fact that I'm being watched. And maybe I can get better at having that not be there, but I think it's there for everybody. And so it's harder to solve problems and all that. Does streaming help with motivation? I mean, it doesn't change much the motivation global to the project. Like, I want to do the project. It helps on specific days. Like, if I get up one day and I'm like, blah, I don't really want to do anything, it's like, well, we'll make a game out of it. We'll stream, and that'll change it up a little bit. Or like, yesterday and today, I was like, hey, well, in fact, I wasn't even thinking about doing the hash table thing this weekend. I was like, instead of going into the office Friday, what if I stay home and try, I didn't know that I was going to succeed, but try in one day to do this Lambda refactor you've been wanting to do. And when I put it that way, I got excited about it, and I was like, all right, let's do it. And same with today's hash table thing that is now done, modulo loose ends. It's like, hey, let's make a little game out of it. Let's stream it. Let's make sure we can do it in one day. So forth. Yeah, the explaining is part of where the brain power goes, but it's also, it just takes energy to stream. It's weird. I get tired streaming in a way that I don't when I'm not streaming, even when I'm not talking that much. Yeah, maybe the eye tracker helps a little bit. I don't know. I don't know, people. sometime, I don't feel like profiling right now, but sometime we'll do a stream where we profile and look at what we just did and whether we can speed up identifier lookup even more. I bet we can. I bet there's just dumb stuff happening and we can get even more than this 20% speed up we've already got. Drugs, yeah. Is there a book you can recommend to be a better programmer? Not really. Not that's about programming. You somehow get a lot more productive when watching my productive streams. Well, right on. If I can help you be productive, that's great. Isn't Mythical Man Month good? Yeah, Mythical Man Month is good, but it's not really going to teach you how to program in any way. And it's also very old, but you should read it. And then read it again later when you have more experience, for sure. How much uptime do we have now? I kind of feel like it's Miller time. Oh, the Robotech is not happening right now. Very sad. Sad. 2 hours. In 6 minutes. Okay. Yeah, don't say that thing about exceptional C++ without a sarcasm tag because people might think you're serious. This is how rumors spread. Did I enable low latency in Twitch? I think so. I checked a box. Okay, here's what we're going to do. I'm going to clap my hands. So a bunch of people type hello, but don't hit enter yet. All right. And when I clap my hands, hit enter, and I'm going to count how much time it is. All right. Ready? 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 Yeah, that's about 2 seconds. It's a little less than 2 seconds. That's a lot of hellos. It seems less than 2 seconds. Yeah. Actually, here's what we can do. Is I can put my Twitch window over here so people can type their chat and see how long it takes the round trip to get back to them on the screen after they type it. Although that's probably under my camera, so let's move it over there. How does that look? Okay, so that's pretty good, right? Would I say that the language is faster than C++? Well, I would say that our feature set is faster than C++. Our implementation is probably not really fast compared to C++ implementations yet because we haven't done that kind of back-end speed work that you really need to do. But our feature set enables you to make programs that are substantially faster than C++ programs, in my opinion. Of course, that also has to be, that opinion of mine has to be tested empirically, and that hasn't really happened either. Yeah, if you're a PUBG player, you don't necessarily want low latency. It is true. What are my thoughts on visual programming? Do I think we'll move away from long lines of text anytime soon? My thoughts are maybe there's something to do there, but I don't think it's for a long time in the future because every attempt that I've seen at visual programming is like trivial stuff, right? Here's what I think. I would like to see someone solve very well the much easier part of that problem. And maybe it'll be me who attacks this because I have an interest in this. I would like to see just good visual output. Like I was saying, I want to see a debugger that helps me see the structure of my program, right? I've never seen one of those that really helped. If I can see visuals that help me understand my program in a way that I wouldn't have without those visuals, and understand it along the many dimensions that I care about it, then we can maybe start along the lines of using visuals for input because we'll have maybe better ideas about how those visuals could be. It's maybe not even the same visuals, but maybe we'll have more of a taste for it. But right now, all the attempts are just, they're toys for non-programmers. You can't really use them to write real programs. Yeah, the UE4 blueprint system is probably one of the reasons why PUBG is so damn slow, by the way. I don't actually know that for sure, but it's my suspicion. Well, we've been working on a compiler. Have I seen Eskel's OPA debugger? I have not. Does somebody want to link me to something about it? And that was a nice low latency reply.
Hi, in this video I want to show you debugger that we work with.
Okay, I'll watch that a little later.
Debugger running right now, and I'm going to start
Did I find the laptop I want?
application that
I bought an Alienware,
I'm going to use that as an example.
but it hasn't been delivered yet.
So in that application, I've added one line of code, which is this. And it says stop and watch, and then you give it a pointer, you give the type of that pointer, and you give a path to where the file is that defines that. So let's start this and see what happens. So here we go. Here's my application. It's starting up. And as soon as it starts up,
That's a nice style.
I'm actually visualizing that data structure, and it's all live in real time. So if I, for instance, change the size of this scale like this, you can actually see the numbers here in width change. And I can actually go in here and I can change this. So that's 3, and then you can see in the application it changes in real time. So what is going on here? Well, this application is basically networking over to this application and telling it about this structure. And then this application goes ahead and parses this NH file in order to figure out the whole structure of it. And then it can figure out how large this data is, and it sends back a message saying, hey, I want some data from that pointer. And the application responds, and then they can go back and forth and update. And this allows me to view the entire data of that structure. And you can also look at something like a pointer. So I'm going to look at the prototype here. I click on that, and I get this, and all of a sudden I download all the prototypes. And this happens to be an array. And I can keep going here. Let's see, I want to find the sphere and add a bunch of floats in it. Here's a bunch of floats.
It's already better than Visual Studio, bro.
Now we can go look at these floats. What's going on? We can pull them out to have them in columns. So this happens to be XYZ data, so I have to do it this way. Now I can go in here and actually edit the number if I want to, but I can also visualize it. So by clicking on this, see, I can draw a graph. So here is a graph of that data. I can also, I can also show a 2D graph, and then all of a sudden you can see it's actually a sphere. Or I can do a 3D one and get it in the background. So here you go. So this is the actual data going on, and I can even click on one of these points here, definitely mess up and blow everything up, but it's still a really, really powerful application. I'm still working on this, and I'm reworking some of the parsing, because basically I had to implement a good chunk of the C compiler in order to do this, and I'm
Yeah, I've met Eskel
starting to
before.
take that a little bit more seriously, so I'm probably
You
going to
know, he's been at the GDC and stuff.
but if
I
you're
don't go to the
interested,
GDC much anymore, but yeah.
test this out. Thank you for watching.
All right. Cool. Cool. Would I ever make an alternative to OpenGL? No. I got too many other things to do. If I made an API, it would be a software rendering API. Should you be watching my streams or working on your projects? Well, I recommend working on your projects. I think we all know the answer to that, but if you want to take a little break and watch streams, I do that sometimes, you know. It's all good. It's all good. I am very happy with the progress made yesterday and today. It's very nice. It's almost like a real compiler at this point. I've got some emails to send. What was this slow, incomplete thing that I said at the start of today? Or did we delete it? Here we're iterating over all members in a block. Okay, we're looking up the entry point name. That's just a regular query. So we'll do that. And here we are looking up member decal. Emit code for member address. The problem here is that member decal might not have a name in some cases. I don't think. I'm not sure. Let's go for the other one first. Let's go for this one. This isn't going to matter that much to fix this because it only happens once every time we do a run directive on a fixed entry point name, which like is only ever like once. But we're just going to fix it for style reasons. Don't I have a find in global? Oh, we deleted that. Find in block. Auto decal entry point. Find in block interp. Entry point atom constants. Oh, no, not constants. Block. That's all. Now we need to get entry point atom. And I think we have entry point atom. That's the funny thing. I think we're downcasting to a string. Let's just see. We do. So who is calling run bytecode with entry point name? All right, that's just passing that onward. Wait, does nobody call this? Does nobody call this run bytecode with one argument? If nobody calls run bytecode with one argument, we are going to be so happy. Like, oh my God. Dude, nobody uses this now. You know what that means? Ba-boom. Ba-boom. You know what that means? 41636. We're only 123 lines up from where we were yesterday morning. Ba-boom. Of course, I mean, it's unrelated changes, but anything we can do to get the lines of code down. Oh, yeah. Oh, yeah. Oh, yeah. Let's see that. See that 0.55. Oh, it was 0.53 before. 0.55. Oh. Come on, 5.3. Okay. I just wanted to see the 3. Never mind that it's 5.39. Never mind that it's 5.39. So I think half of the frickin' declarations, it probably doesn't take much time to parse all those declarations and discard them, but I think half of them are not necessary. I'm actually... Yeah. Yeah. I should teach Checker how to set up eye tracking for spy party streams. That would be good. I'm going to send him an email right now. I'm going to say, compose Chris Hacker Eye Tracker. I have a stream where I talk about everything that is wrong with Rust. Does anyone have a link? Someone probably has a link. I don't talk about everything that's wrong with Rust. I talk about why it is not really the language that I want to use. Have I become a more positive person over the years? Yes, but part of the reason behind that is being able to make some things that react to the things that I feel negatively about, right? So like I don't like C++, so I can make an alternative and it's a productive place to put energy. What C++ compiler do I recommend? I don't know, man. I just use Visual Studio. Is my compiler built with SSA from scratch? No and yes. Okay. So we've got one other slow incomplete. This one. Okay, this definitely could be anonymous. here's what we're going to do. Okay, so if member decal identifier else, oh crap, no, we can't, right? No, because we need this. This gets added up for everybody. Wait a minute. 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 Don't we already have this information? So, you know, we're going and we're adding up the sizes of all these guys. Into the offset. But don't we have like base address? Doesn't that get set when we size the struct? I think this used to be more complicated because of SOA or something. So when we size the struct, we need to do all this stuff. So we go over all the members. Like, why don't I just set that here? Okay. Before I do anything, did I check in? I don't think I checked in. So if we're going to do something scary like this. All right. I want to first of all see if I'm putting this information somewhere. And we can like comment out all this SOA code because it's not in use right now. Hopefully this, are you kidding me? Are you kidding me that, oh, no, that's all for SOA. All of this code, this loop is only for SOA, which doesn't even happen right now, right? Okay, yeah, base address gets set. That's what I was saying. All right, all right. Well, here's what we're going to do. We're going to get our line count down. We're going to get our line count down. By just doing this, bruh. And then this. None of this is going to matter because in the new implementation for SOA type things, it's going to be sufficiently different from the old implementation that I will probably need to do all of this again differently. But how is that? We don't need to do debug build. This is just going to work because we don't allow SOA right now. It's deprecated. It is deprecated. Deprecated. All right. Oh, what? What? You are kidding me. Do I set things to SOA in? I thought I don't allow it. Well, okay, well let's get rid of that. Compiler. Deep copy. Let's skip the Sokoban for a minute. Preload. It's just comments. Print. I already looked at that one. Okay, Sokoban. Soak, that's not SOA. Entities. Entity manager. Yeah, nothing is SOA. So what is going on? Did I just goof? Did I just goof? Can I tell you about the new SOA idea? Well, the general idea is to provide a good way for you to just specify a memory layout for a struct separately from the data declaration of the struct, right? So you could have different layouts for the same struct and it could be automatically converted and all that. The question is, like, what's the best trade-off between language complexity and benefit? And the other question is, when the hell am I going to implement the feature that sits under this? And the answer to that is, well, it's going to come off the list eventually, just like all these things do. Oh, wait, it wasn't compiling that crashes. It was running that crashes. I'm so confused. How? Wait, now it works. Was I the x64 one crashes sometimes, so maybe I built x64. It's working. What am I talking about? I don't know. I think there's still a weird random crash somewhere that we have to debug. But, you know, it is what it is. I am stuck. I am so stuck. Okay. That gets rid of all the. Let's run. Oh, let me get rid of this thing. And we'll run tests again. Kablam-a-dam-a-dam-a-dong, a-ding-a-dong, a-ding-dong. Comment out deprecated SOA address generation code. Count 41587. So now we're only 74 lines up from where we were yesterday morning. Yeah, it might be. So here's the thing about the old SOA version, is it wasn't the right compromise, because I don't know if it's not right, but it seemed not quite right, because you really want enough versatility to do AOSOA of arbitrary lengths. And we didn't really have good polymorphism back then. So SOA was implemented as like a fat pointer, right? If we use polymorphism to do it instead, we could go back and have everything be AOSOA. And that would be fine. It'd be fine. I don't know, man. Like I would do SOA again, even if what we end up with is sort of syntactically a lot like what we had before. I would just re-implement it because I think I can do it better this time. But I think the feature that we will have will be better. How do we fund all the work? With video game proceeds from our video games. From our video. Yeah, AOSOA is exactly like buckets of SOA chunks. So it's like if you're AOSOA 16, then if you have 300 items in an array, it's 16 at a time. And then the last bucket is just less than 16, right? And probably there's padding in there and stuff. And the good thing about that is that if you want to look up a subfield of your struct, because these chunks are constant size, then you don't have to do dynamic math at compile time to figure out the address of the thing, or dynamic math at runtime, because you know it's just a constant offset. Whereas arbitrary SOA, like I had before, was a non-constant offset. Hey, William Bundy is hosting. Yeah, thank you. Thank you, William Bundy, for up to 7 viewers. Speaking of video game proceeds, do you think Android devices are powerful enough yet to run Braid? And if they were, would you consider porting Braid to Android? They are definitely powerful enough to run some version of the game. We might have to cut down the depth complexity a little bit, the number of pixels that are drawn, but they could run it. The problem is just making games for Android is a nightmare. And then making money off any non-free-to-play game on mobile is a nightmare. So, like, why would we do it? It's just, it would make us miserable and we would get nothing out of it. Is the PC experience significantly better than the iPhone experience? I think so, but if you're having headaches and stuff, it might be due to the way we did motion, or it might just be due to the color. Like, we definitely get people who say they get motion sick on the PC and console versions of the game, and I never figured out what it was. I think it might just be something to do with our art style is weird. Like, I really don't understand why we have that issue. So, yeah. I don't know. Yeah, FOV is also adjustable on iOS. What did Constance tell me? Constance told me I should try to reduce complexities like this. Now that we no longer have global scope optimization, can we just roll this into the data scope handling above? Oh yeah. I'm a little too tired to do this right now, but maybe later tonight or maybe tomorrow. Who knows? But Constance is right about that. She has the right idea. Yeah, I think it's about time to take a break, and I may come back on later tonight and stream. FOV should be adjustable on iPhone. Yeah, you tap the tab in the upper left corner of the screen, and it takes you to a menu. Thanks everybody for stopping by. Let's host some more PUBG, right? Let's do a little Choco Taco for a bit. He's my favorite PUBG streamer, and he's on. Maybe I'll see you guys later tonight. Maybe I'll see you later.